Hi everyone, today is a lecture about UV visible spectroscopy. First we have to define what's meant by spectroscopy and electromagnetic radiation. Spectroscopy is a branch of science that deals with the study of interaction of matter with the light. Spectroscopy here, branch of science, deals with interaction with matter. Matters means a sample and light. Interaction between light and matter produce data. Use data to know qualitatively or quantitatively data of the analysis. Is a branch of science deal with the study of interaction of electromagnetic radiation with the matter. Interaction between electromagnetic radiation, it's light, but in accurate term it's called electromagnetic radiation, and the sample. This interaction produce data, use it to calculate qualitatively or quantitatively analysis. What's meant by electromagnetic radiation? Its radiation consists of discrete package of energy which are called photon. This is source of electromagnetic radiation. This photon consists of waves. This is called waves. Is magnetic, consists of magnetic field and electrical field, and there is many terms that used to express this electromagnetic radiation, like frequency, wavelengths, and whatever. We have to define this term. Frequency is defined as the number of oscillation in the electrical field per unit time. Here, number of oscillation in unit times. If frequency is hertz, 1 hertz equal 1 cycle per second. This 1 cycle, this is 1 cycle per second. How many cycle per second can this radiation produce or go is the number of oscillation per unit time. The wave number here, the distance between two maximum or minimum of wave of electromagnetic wave, like this. This is the wave length. This is the wave length. The distance between the maximum or the distance between the minimum. Also, this is the wavelength. So, what's the relationship between the wavelength and frequency? The C equal frequency multiplied by the wavelength. C is the speed of light, V is the frequency, and Y is the wavelength. And energy equal H multiplied by V, or equal H multiplied by C divided by lambda. This lambda is the wavelength. H is the Planck constant and V is the frequency. So the energy equal H, which is the constant, multiplied by frequency. When the sample absorbs electromagnetic radiation, it undergoes change in energy. There is interaction between electromagnetic radiation and the sample. This interaction causes change in energy of the sample. This interaction is easy to understand if we assume that the electromagnetic radiation consists of a beam of energetic part called photon. So electromagnetic radiation consists of energetic part called photon. So when the sample absorbs this photon, the sample change its energy or acquire energy, and this change can be produced as a data. Use it for qualitative and quantitative analysis of the sample. Here, this is the energy equal H multiplied by frequency. V is the frequency. C is the speed of light, which is constant. 3 multiplied by 10 to the power 10, and lambda is the wavelength in meter. In UV visible spectrum, the wavelengths usually expressed in nanometer, and nanometer equal 10 to the power minus 9 meters. So, from this equation, there is a diagram a direct relationship between the energy and frequency. When the frequency increases, the energy increases, but there is inversely proportional relationship between the energy and the wavelengths. When the wavelengths increase, the energy decrease, and when the wavelengths decrease, the energy increase. This is electromagnetic radiation. It consists of many parts. Different parts react differently with the sample, and so produce different data to use it for qualitative or quantitative analysis. This is the wavelengths. Here is the gamma, which is the highest energy. This is the energy 10 to power 10. This is the highest energy and the lowest wavelengths. But radio frequency have the highest wavelengths and the lowest energy. This is inversely proportional between the wavelengths and energy. So the gamma rays, X-rays, UV, visible, IR, microwave, and radio frequency. This is a different part of electromagnetic radiation. Every part reacts differently with the sample. Here's the same. Energy is proportional to the frequency, and frequency is inversely proportional to the wavelengths. Like here, this is a type of radiation, this is the frequency range, this is the wavelength range, and this is a type of transition. See here, the gamma rays, which have the highest energy, its interaction with nucleus of the molecule. This is the gamma rays because it has highest energy. X-rays react with inner electrons. Ultraviolet and visible react with outer electron. It's a low energy compared with gamma rays and X-rays. Infrared and near infrared react with outer electron molecular vibration. This is the molecular vibration. This is called infrared spectroscopy, and this is called UV spectroscopy. And microwave react with produce molecular rotation, electron is being flipped. This is NMR. So different part of electromagnetic radiation react with differently with nucleus. Here react with electron because they has highest energy, while this is react with molecule because of lowest energy. So in this course we discuss UV spectroscopy, which is outer electron transition. We discuss infrared, which is molecular vibration, and we discuss NMR, which is molecular rotation or skin. And there is another method called MS, and have different non-react with electromagnetic radiation, different process. Here there is the white light, and this is the prism. The prism disperses the light to different light according to their energy. So this light have different energy and have different frequency, and so the wavelength, and so they have different energy. This is the wave number. The wave number violet 400, 420, and so on. This is the dispersion angle of light.